Hi everyone, myself MGV Saideya. I am pursuing second year BTech, bearing roll number 24BQ1A04A2 from EC department. Today I want to tell the seminar topic about PN junction diode. Introduction to semiconductors and PN junctions. What are semiconductors? Semiconductors are materials with electrical conductivity between conductors and insulators. Silicon and germanium are the most common semiconductor material used in electronic devices. There are two types. Pure semiconductor have limited conductivity at room temperature. Doping with impurity creates N-type and P-type materials. PN junction from the foundation of all semiconductor devices. At very low temperature, it behaves like an insulator. At higher temperature or when impurity are added, doping, it conducts electricity. Example, silicon, germanium. In short, a semiconductor is a substance that can conduct electricity partially and its conductivity. They can be controlled by temperature, light or doping. Formation of p-n junction and depletion region. P-type material acceptor atoms creates holes. Boron is commonly used as dopant. Depletion region. Electrons and holes recombine at the junction, creating an electric field that prevent further diffusion. N-type material. Donor atoms provide free electrons, negative charge carriers. Phosphorus is typically used. Energy band diagram of p-n junction diode. Conduction band, where free electrons exist and can conduct electricity. Valency band, where electrons are bound to atoms in covalent bonds. Band gap, energy difference between valency and conduction bands. The energy band diagram illustrates how electron energy levels change across the p-n junction diode. From the diagram, we observe that p-n junction at a hole and p side and n side we have electrons. Forward basic operation and current flow mechanism. Number 1. External voltage applied. Positive terminal connected to P side, negative to N side reduces the potential barrier. Number 2. Depletion region narrows. The electric field opposes the built-in potential, allowing charge carriers to cross the junction. Current flows. Electron flow from N to P region, holes flow from P to N region, creating forward current. Reverse bias operation and breakdown phenomena. Reverse bias characteristics. When the P side is connected to negative terminal and N side to positive, the depletion region widens significantly. Minimal current, only small leakage current flows due to minority carriers. Breakdown voltage. At higher reverse voltage, avalanche or Zener breakdown occurs. From the diagram, we see that where P-type field, depletion field, electrician field, MS spanner of high generation, avalanche breakdown. In reverse bias diode NN. Current, voltage, characteristics and diode equation. We see Shockley diode equation we known as I equal to Is of e power qV by nkt minus 1, where I equal to diode current, Is equal to saturation current, Q equal to electron charge, V equal to applied voltage, N equal to ideality factor, K equal to Boltzmann constant, T equal to absolute temperature. If we saw graph between current and voltage, it is a line passing through the origin, y equal to mx. The exponential relationship between current and voltage demonstrates the diode rectifying properties. Types of diode and their application. Light emitting diode convert electrical energy to light through electroluminescence used in displays, indicators and solid state lighting system. Photodiode converts light into electrical current used in optical communication, light sensors and solar cells. Zener diode. Operation in reverse breakdown region. Maintain constant voltage, essential for voltage regulation circuits. Schottky diode. Fast switching with low forward voltage drop. Ideal for high frequency applications and switching circuits. Practical consideration: temperature effect and parasitic element. Temperature coefficient: forward voltage decreases by approximately 2 millivolt per degree Celsius. Increase critical for temperature compensation in circuits. Junction capacitance: parasitic capacitance effects. High frequency performance varies with reverse bias voltage and doping concentration. Series resistance: bulk resistance of semiconductor material limits currently handling capability and effect efficiency. Real world applications: rectifiers, voltage regulator, and signal processing. Diode clipping limiter. Power electronics. Diodes are fundamental in converting AC to DC power, protecting circuits from reverse polarity, and regulating voltage levels in power supplies. Silicon forward drop 0.7 volt, typically forward voltage. Signal processing used for signal clipping, peak detection, frequency mixing, and amplitude modulation in communication systems and audio equipment. Rectifier efficiency 99%, breakdown voltage 1000 volt, high power applied. Some other applications of PN junction diode: rectifier, AC to DC conversion, used in off full wave rectifier to convert alternating current AC into direct current. Switching applications: acts an electronic switch in digital logic circuits and other electronic devices. Clipping circuit, used to clip remove a portion of the input signal without distorting the remaining part. Clamping circuit, used to shift the signal where level waveform either upward or downward. Voltage multiplier, in voltage doubler, tripler, and quadrupler circuits to generate high DC voltage from a low AC voltage. Signal demodulation, used in radio receivers for detecting AM signals. Reverse current protection, placed across power supplies or batteries to prevent damage due to reverse polarity connection. Logic gates, diodes are used to design basic logic gates like AND and OR in diode logic circuits. Solar cells, a solar cell is essentially a large area PN junction diode that convert light energy into electrical energy. LED, light emitting diode, a forward bias PN junction diode that emits light. Some real life examples of PN junction diode applications: and mobile phone chargers. Inside every charger, a rectifier circuit using PN junction diode convert AC from wall socket into DC to charge the battery. Second one, power supply units, computers, TVs, radios. Diodes are used in bridge rectifier to supply DC voltage to electronic circuits. LED bulbs and indicators. The LED, light emitting diode in bulbs, remote control TV power indicators, and traffic light are practical forms of PN junction diodes. Solar panel. Solar cells are PN junction diodes that convert sunlight into electricity. And radio, television. Diodes are used in AM FM radio receivers for demodulation, extracting sound from radio signals. Battery protection in laptops and cars. Diodes prevent current from flowing back into the charger of alternator when the battery is full. Clipper and clamper circuit in audio systems, used to limit voltage spikes in the speakers and protect audio amplifiers. UPS and inverters. Diodes are used in rectifier inside UPS inverter circuit to maintain DC power for backup. In PN junction diode is also used in emergency lights and torch lights. The small LED in torches is a diode on forward bias, converting electricity into light. It is also used in reverse polarity protection. In cars, diodes are placed near the battery so that if you connect the terminals wrong, it prevents damage to the electronics. So whenever you charge your phone, switch on a LED or listen to the radio or use a solar light, you are actually using a PN junction diode in real life. Today I tell the seminar topic about PN junction diode. These are the some example for the PN junction diode in real time life. So thank you for giving me this opportunity.